Okay, we still have people joining the webcast today, so I think we'll wait for another couple of seconds before we actually get started. Right, we're at 2 minutes past the hour, at least according to my clock. So I think with that, we can kick off. If people are joining afterwards, no problem. I think with that, we are good to go. So, hello and welcome. Welcome everybody to today's Analytics and Data Techcast. My name is Hans Fiemann. I'm your host for this session. I'm actually moderating this webcast in my role as a member of the A&D Oracle user community. I sort of have my A&D OUC hat on, right? I'm assisting this community of hardworking volunteers, that organize these techcasts, and not only organize these techcasts, but also other things which I'll come to in a moment. In my day job, I'm actually a product manager with the Oracle Spatial and Graph team. And what we'll hear about today from Martin Voss in his talk is how he is integrating data silos with linked data in the Oracle database. Now, before we come to that, I have a few organizational announcements to make, and I also have a couple of housekeeping items. So let me quickly get started with that. First of all, you may or may not know that we're arranging these techcasts on a regular basis, right? We're also recording them, so that you can, in case you missed them, you can watch the sessions afterwards. All these recordings and also the slides, they go into the A&D OUC Techcast archive, right, which you can find on our website under Techcasts. Surprise, surprise. And as you can imagine, right, we're always interested in new content. So if you have a topic to share, or if you have an interesting project to talk about, do please submit your proposal under the link which you can find on this slide. The A&D Techcast subcommittee will then review your proposal. It'll select the best proposals. They'll slot them in. And hopefully, we'll slot you in for a future Techcast. What we have coming up next is the winter Techcast Days. Right, these Techcast Days are a bit different from the individual Techcasts like this one, right? In that they consist of 3 consecutive half days of talks. In this case, they're on February 15th through 17th. They're kind of like a shortened online version of the in-person conference, which we used to have every year, at least, before the pandemic. And I know that we have a couple of participants on today's webcast who are particularly interested in the spatial features of the Oracle database, because this topic today is kind of on the intersection between the spatial and the graph technology. So for those participants, the February 16th may be particularly relevant, because that's the sort of the spatial day, right? We'll have a talk by Outfront Media on how they're using spatial technologies for site planning. We'll have a best practices session on Oracle Spatial. There's another 2 talks, one on Spatial Studio, one on the spatial features of Apex, all around spatial. But there's also talks on machine learning on February 15th. There's talks on analytics on the 17th. So lots of interesting content, I think. So stay tuned for that. And one more thing, you can keep in touch with the rest of the A&D community on social media. You may or may not know, we have a Slack workspace. The link is here. So you can register yourself. There's a LinkedIn group. You can subscribe to the newsletter and so on. And by the way, there's no need for you to quickly scribble down all these links, right? Carrie will post them in the chat in a moment if she hasn't done so already. Oh, and talking about chat, if you have any questions to the speaker during today's presentation, right, please do not post them in the chat. Please put them into the Q&A box, because that'll just make it easier for us to keep track of them. Right, so now on to today's talk. It's my great pleasure to welcome Martin Vos as our speaker today. Martin is currently a data architect at Redforce in the Netherlands. He has over 25 years of experience in GIS, data migration, data integration, and I can actually testify to that. I've met him in February '96 on a project, and back then he already had a lot of knowledge around these topics. During the past 7 years, Martin's been working intensively with the Oracle RDF Graph technologies, with a specific focus on RDF in conjunction with the OGC GeoSparkle standard, so on the intersection between Spatial and Graph. And during that time, Martin has developed a system for manipulating native RDF and spatial data, and he's done that using Oracle Apex, using Oracle Jet, in combination with open layers, and that's what he'll be talking about today. As you can probably guess, his areas of focus are linked data or linked open data, data integration, geospatial technologies, but also big data, data migration, and so on. Before I hand over to Martin, I'd like to say a few words about linked data and how linked data can be used for data integration, because I'm not sure if everybody on the call is familiar with these topics. So let me just quickly show you a little piece of the data model which Martin will be using in his talk today. I mean, obviously I can't give a crash course on RDF knowledge graphs in just 60 seconds, but let me try to at least give you an idea of what this is all about, right? One fundamental concept of graphs, at least graphs based on the resource description framework, or RDF for short, is that you can uniquely identify every resource. Like if you take this guy here, right, that is a specific pipe in the sewage network identified as combined sewer 93, right? And that resource that has more information linked to it, right? For example, it says it's of type combined sewer, and combined sewer in this system has a very specific meaning, right? I think it means that it is both for wastewater and rainwater, but Martin might know better. So that specific meaning is associated with this resource. It also has a label associated with it. It also has additional properties linked to it. And that information is always stored in the form of so-called triples, right? So the combined sewer 93, that's the subject. Type would be the predicate, and combined sewer would be the object, and so forth. Now, what you can do is, obviously, you can retrieve any information that's directly linked to this combined sewer 93, but you can also make use of the chains of relationships and then retrieve information which is indirectly connected. Right? And this capability obviously is very useful when you want to integrate information from different parts of your model or from different data sources altogether, right? So as soon as you define the manhole on the left, right, the inspection manhole 17, that's this guy here, right? If you have that, then if you link that, if you link this guy to the sewer 93 using some connection, then you can easily determine which type of sewer is connected to that specific manhole, and what are the labels associated with the sewer associated with the manhole, and so forth, right? And the language, the query language to do so is called Sparkle, which I don't know if you know, but which the Oracle database understands, right? There's a ton of additional, RDF knowledge graph concepts which have, all kinds of benefits, like you can logically infer information and so on. But for today's talk, I think it's probably all you need to know, right? And with that, I would like to finally hand over to Martin. Right, Martin, maybe you can grab this screen share, and then the floor is all yours.
Okay, I will start sharing my screen. Share yes. Portion of the screen. Share. Sorry, I have PowerPoint. Start this one. Say. So.
Okay, perfect. Excellent. All right, off we go.
Okay, today I want to talk about integrating data silos with RDF. So my name is Martin Vos, and like Hans already mentioned, I mainly deal with data management issues like linked data, data integration, geospatial, and so on and so on. So what's this session about? This session is about data integration based on an RDF graph. Our solution is built on an Oracle converged database with RDF integrated. And on top of that, we have a Redforce Lydia solution. And we will show you in the demo a sewage system with linked data. Which technologies did we use? We use RDF Graph, Spatial, JSON, relational, SODA, REST. And for the applications, we used Jet and Apex. Then we will also show you a solution for the chatbot. We use so-called transaction containers, which are in fact long transactions. Then we have GeoServer, which is an open source map visualization tool to expose the data to the outside world. Then we have Protégé, which is a tool for modeling RDF data. And everything we developed is in the cloud available. So Redforce is a subsidiary of the DPA group. We started up in 2016, and we are specialized in linked data and especially geosparkle. And we used Oracle technology for our stack, and our first product was in 2017. So why did we choose for the RDF graph? We wanted to use as little as possible a physical data replication. And linked data makes it possible to use internet technology, which means that you have everyone can in fact connect to it. It is very cheap and it has a lot of advantages. We also wanted to create maps with smart geospatial data. I will come to that part later. And what also was important, that everything was based on open standards like W3C and the OGC standards. So which problems do you face when you want to have 360-degree views over silos? Here you see, in fact, the main three problems you will see. The first one is same name, different meaning. For example, Apple. This could be a company, but it also could be a fruit. The second one is that you have different names for same meaning, like sofa and couch. And the third one is that you have different structures. In one silo, you could have name and address as one entity, and in another silo, this could be two separate entities. So to place a virtual layer on top of this all, with all about meaning, you can combine all these things together. And in fact, ontology is all about meaning. So what is in the Oracle database available? Oracle made an implementation of the linked data based on the W3C and OGC standards. And so you can use Sparkle and GeoSparkle. And on the other hand, you can combine it with the traditional strengths that are already available in the database and combine those two. And everything is also available in the cloud. So RDF, in fact, operates on subdomains. And there are out there a lot of ontologies, models, in fact, which are freely available and which you can use for in this subdomains. With Sparkle, you can make queries which go over all these subdomains and retrieve the data. And there is also GeoSparkle, which extends, in fact, the Sparkle. And there you can have also geo-related options in a Sparkle query, like what's inside a particular area. So our demo is based, in fact, on two subdomains. The first subdomain is geospatial subdomain. The second one is, in fact, the sewage subdomain. And then we have a viewer which combines those two subdomains so that you can view the combined data. Then we will show the chatbot. With the chatbot, people can report things about public space. And via a REST service, the data is sent to the back office. And in the back office, we will create the necessary RDF data for a subdomain for the messages, create the objects for the geospatial part as RDF, and we make a link between those subdomains. And then again, you can view that part with a third-party viewer. You also can do a third-party integration. Here, for example, if you have a contractor which does measurements on sewage pipes, for example, depth and location, then they could extend that data with metadata from the ontology, send it via the REST to the back office, and there again, we create the necessary RDF data for in the sewage subdomain, the geo objects for in the geo subdomain. We link those two together, and then again, the viewer can show the combined data. We also use so-called transaction container, which is in fact nothing else as long transactions. And at the certain point, if all the changes are correct, you can say save, and at that moment, the data will go into the subdomain. You can use this for different types of scenarios like planning or things. Then we can also exchange data with contractors. For example, if you have a municipality which has a contractor who does the data capturing, and if they are finished with the data capturing, they can exchange the data with the transaction container from the municipality, and they can then first do a kind of quality check to see if things are correct before they submit it into the subdomain. But we also can do a remote access on the contractor's transaction container. So since we have, in fact, all the metadata in place for the the metadata for what's in the sub domains by means of the models that are in there. And on the other hand, we have the functionality, which we also have metadata for, and we have linked those two together. So then it will be possible for a customer to just select the data. And with that, we can generate a new application which has the data and the functionality. And here is a closer look at that application. And there you see how the ontology is reflected in the application. So this is the model, and this is the application. So what preparation did we make for this demo? We took some geospatial relational data, asset data, converted it to the RDF graph, and used two ontologies, one public for sewage, and another one we developed ourselves for the geo part, because an object is in fact on the map is more than just the x and y coordinate of an object. We will see this later on. So we developed this more from the point of view what's on the map. Then on the right side, you see the applications we have. We have the JET application, which does the maintenance for the geo part. We have an Apex application, which does the maintenance for the sewage ontology. And we have a viewer, which can show the combined data. We have 2.5 million triples now in that database at this moment. So what's in fact this geo ontology about? I have a little example here. It's about a power network, but I think it shows quite well what is possible. So in green you see low power lines, and in red are the medium voltage power lines. And then we have here a cross section. That means if you would stand on this point and you would look into the ground, you would see that this middle voltage power line is below the low voltage power line. So which kind of links do we see in this map? First of all, you see this is the description of the material which belongs to that middle voltage power line. There you see a second description, the same description on the same power line. Then we see that there is a symbol which reflects this medium voltage power line, and there is the same annotation like those two, which is pointing towards that symbol. So with our geo ontology, we have the possibility to define all these geo objects and the links in between of them. And then we, of course, can with Sparkle query and fetch every single object or everything what is linked together. So if we now would delete this power line via Sparkle, then this would be the result, which means the power line has been deleted, the annotations have been deleted, the symbol has been deleted, and this annotation also has been deleted. So this also, if you don't see those things in the map, it will be deleted without seeing those objects eventually. This makes everything very user-friendly and keeps everything consistent over all the applications. So how does our ecosystem look like. We have the subdomain with the sewage ontology, and on top we have this Apex application, which can manipulate the sewage ontology. We have the geo ontology with an Oracle Jet application, which can manipulate the geometry. And we can make links in between so that a third-party viewer can show the combined data. So in short, the summary, RDF is an open W3C standard. RDF is predestined to link data based on meaning. We can link data from different silos, in fact, subdomains. And we can make use of the OGG GeoSparkle to extend Sparkle queries with geo-related options. So now it's time to go to our demo. So I will stop sharing. And share my screen again. Basic share screen, share. So, do you see my screen yet?
Yep, that works.
Okay. So I'm first going to log in those three applications. And I think this one is timed out or not. So, okay. So let me show in short and recap. We have the data from the sewage ontology in this subdomain. We have the geometry in the subdomain. And now, first, we're going to take a look at the viewer. So in here, and the data is from the town of Almere, which is near Amsterdam in the Netherlands. So if I'm now going to zoom in, then you will see the data. This is in fact the geospatial part. Unfortunately, all the text is in Dutch, but so, and if I zoom further in, you will see other objects. And if I click on one, then you see now, in fact, the combined data. This is coming out of the sewage ontology, and this is the geometry for it. So if I have two pipes, so that's that part. So now let's make some changes. So I will select my application. Sorry, this is the wrong one. To select that one. So, okay. So our task is, as an engineer, to document a sewer pipe. And in fact, the first thing we want to do is we want to create a working area. Since this is a multi-user environment, we want other people to know that we are working in a particular area and they shouldn't work in that same area. So I now can draw an area, working area, and I can make an annotation on that working area. And as you see, this is a kind of dummy number because at this moment there is nothing connected with this working area. So I can save this one. Now I'm going to the sewage part where we also have working areas. And I create another working area. And I say sewage. And I say save. So what has happened now? If we look at our system again, I now created, in fact, in this subdomain, the geo part for this working area. I also created an entrance in this sewage ontology in this subdomain. And what we are now going to do is to link those two things together. So if I go to my working area and I choose this part and I say mark that row, and I go to my geo part, select the working area, and I say make link the view. Here it says it is allowed and it has been done. So if I refresh this, now you see that the data, which my email address, is now in the map. You can save this one. If we have a go back to this overview, that means that now, in fact, the data that was in this subdomain has been transferred in the geometry. That means, in fact, I can use every object in this subdomain to expose it in the geometry. And if here were another subdomain, like financial data, I could also expose financial data in the geo system. So we could have two departments which would have different thematic maps on the same geometry. So now we are going to look at this part because we have connected those two. So let's see what has happened here. So if I go to that part, and here we see that this working area is now in real time in the viewer. So let's go back to our task. Our task was to create a sewage pipe, document that part, so I can draw sewage pipe. Sorry, this is not the one I wanted to draw, so I do, and I want to create that one. So let's create that one, make two annotations to it, another one, and we save it. Now we are going to the sewage pipes. So let's create an entrance in this sewer ontology. 2021, 15th, and this drop down is coming from the sewage ontology. So these values are defined in that ontology. So if I, for example, it's in Dutch, but concrete, and let me make it round. So I'll say save. Now, again, we have created the geo part, we have created the sewage pipe, and now we are going to connect those two. So going back to the sewage pipes, and here it was 2021. Let's select that one. So I again say I'm going to mark that what's in the sewage ontology, and I'm going to create a link for it. The link has been created, and if I refresh, now you see that the value concrete, which was here the material, is now in passed to the geometry. So I can save this one. It has been saved, so let's go now to the viewer. And there you see it has in real time created this part. So what happens if we change this material to HDPE? It's another kind of material, and say save. So this has been saved. So in real time, if everything goes, you see that it immediately has changed the data in the viewer. So the other thing I wanted to demo is if I wanted, let me get this filter cleared. So now suppose I'm in my geometry, and in fact I want to know what data is connected with this sewer pipe. So I can then say, bring this to the sticky board. Then in my Apex application, I can say zoom to the part that I've got in my sticky board. Then you will see it has selected that the data that belongs to that pipe. We can also do the opposite way. So if we have selected the data in the sewage ontology, we want to know what is connected to the geometry, we can bring this again to the sticky board. Then I can say select what's on the sticky board. And here you see the thing I mentioned before about these smart geo objects. Like you see, it has selected 3 parts. That is because the system knows that those 2 annotations belong to that pipe. So I now give you another demonstration. If I go into delete this one, you see that the annotations are still in the map. But if I'm going to save this, then it knows the connections, and it will delete also the annotations. And if we go to our viewer, then yeah, it's in the cache, but everything is gone, as you can see. So now I want to show something about the chatbot. So let me first show you what's to recap. So we will see the chatbot, which can make reports about public space. It will be sent to the REST service. The REST service will then create the objects in this subdomain. It will create the geometry. It will create the link in between, and then in the viewer we can see all that data. So let's start the chatbot. And now I want to link those 2 together. So I have to move my map a little bit. So we normally you have the positions of your mobile cell phone, which will be transformed. But for now we have, for the demo, we have some fixed positions. So we want to report, we are in the road here, and we see a loose drain cover. So we want to report that one. So the loose cover, and then we give our location. And it says it has been done. So, and here you see the loose drain cover has been reported and directly put in the ontology for the geospatial part and the message part. So as we walk along that road, we see a hole in the road. So we want also to report that one. So sewage, and we say hole in road, location. And if we zoom in and zoom out, you will see that we have now that also reported. And if we go to our sewage part and go to the chatbot, then you see it has also created the data in that part. So that means, again, if I show this, the data here in Apex was that part we saw, and we saw here the viewer, which is also the data was shown. So that's in fact what I wanted to show you today. So let's wrap up. What have we seen in our demo? We have seen the Oracle RDF Graph. We have seen 2 ontologies being used. We have seen that we have linked all kinds of data in silos, subdomains. We have seen smart geo objects, which is in fact linking all kind of objects together in a map. We have seen the Sparkle we've been using. We saw that we could directly change triples via Apex and Jet in the graph. We have seen the third-party viewer. We saw REST services with the chatbot. And what we didn't show now, but is implemented, is that we can generate applications, we can do data exchange and REST API for third-party integration. So if anyone is interested in collaborating with us in your region and in a specific industry, just contact me, I would say. So I would like, for one remark, that is just for the Dutch people among us. In fact, this is all about common ground. So now I would like to hand over to Hans again.
Right, Martin, perfect. That was great timing, and I love these presentations with so many demos. Thank you very much for that. I have a quick question on the Q&A system for you. Question from Wolfgang, who is asking, what is the name of the third-party viewer which you are using here? And I'm not sure if it was the standalone viewer or if it was the visualization component inside of your application. Maybe you can say, maybe you can comment on both.
That viewer was one map that is just from a third-party company with which we work together, and the maintenance part was a Jet application we developed ourselves.
Okay, excellent. Thanks a lot. Hope this answers the question. If there are any more questions, do please put them into the Q&A box, right? Don't put them into chat, put them into the Q&A box so that we can keep track of them. Right, if you need a little more time for thinking, okay, no open questions. Okay, we got that sorted for the time being. But if you have any, then do put them into Q&A. Let me just quickly share my screen again, just in case you are interested in this topic in general. We have a couple of links collected for you here where you can find more information. What I can recommend I mean, obviously, first of all, we have the Oracle landing page, www.oracle.com/go/graph or /database.graph. Both would lead you to the same place, and a couple of sort of generic links on linked data altogether. If you've missed Oracle Database World, there was a presentation on graph technologies combining property graph and RDF graph by my colleague Melly, which you can find under the link, which is the fourth one in the list here. And there's also a slightly outdated but still very educational example from my point of view on our Oracle Spatial blog, which describes how to build a knowledge graph using the Oracle Public Cloud. Now, the public cloud has changed a bit since that was created, but still the concepts are very valid, and it uses geospatial technologies, geosparkle in particular, as part of the blog post. Our blog post series, actually, it's 3 parts as well. So I can recommend that. Now, still no open questions to Martin. Anybody? Any questions still? Last orders? If that's not the case, then let me at least take the last couple of seconds to remind you of the upcoming Techcast Days, which we'll have February 15th through 17th, 3 half days full of user-based, project-based experience, best practices, and the like. Day 1 is on machine learning. Day 2 is on the spatial technologies. Oops, somebody is moving my slides ahead. The second day is the spatial days of February 16th, which is the Wednesday. And on the Thursday, there'll be the analytics topics. You can find all the details and the registration on the Analytics and Data Oracle User Community website. And if there are no more, there's a question from Shuri to Martin. Martin, maybe you can answer that one. The question from Shuri is, how is the RDF data, so 2.5 million triples in total, distributed to the 2 ontologies and the RDF instance data? Do you have a concrete answer to that?
Yes, we have also developed a tool which also is developed with Apex and Oracle Spatial, and that with several masks forms in that, we can transform that data to the triple data, and it uses, in fact, already our metadata we have in place for to do the maintenance, which you saw in our application in the demo. So in fact, it uses the metadata we have in place already, and then we use Apex with spatial functionality and so on to bring the data into the RDF format.
Okay, great. Thanks, Martin. There's one more question in the meantime from Björn from Germany this time. Question about analytics. Do you also have an analysis part of showing all defects or all changes in a given time? Right. So can you run an integrated analysis on the entire data set?
Yes, that's the nice part, but we didn't show that yet. But in fact, we can use all this data with Oracle Analytics. So, and if in the graph we have lineage, which can be modeled with triples, then in fact you have the possibility with Oracle Analytics on top of this data to query, in fact, every possible aspect of the graph.
Okay, excellent. So there's potential for more demos, and I mean, you have Martin's contact details. Anybody who is interested in seeing more, feel free to reach out to Martin directly. And as he was saying, he is also interested in finding collaborators in crime. So if anybody would like to work with him on these types of technologies, then feel free to contact him. I hope this has been useful. As usual, we put the recording onto the ANDOUC Techcast archive. The slides will also be there so that you have all the links which we have been talking about, which also Kay has been putting into the chat. And with that, I would like to thank everybody for their time. Thank you also for the folks who were working tirelessly behind the scenes. So Carrie in particular, Melly for helping out with the Q&A, and the other panelists, Peter van Bentum, thanks for joining us. Shintaro, thanks for all your help. And with that, everybody, I wish you a great rest of the day and hope to see you soon. Thanks a lot.